Hello guys, in this video we will be looking at rotational symmetry. Now please don't confuse this with symmetry or lines of symmetry. Although they have something in common, they are slightly different. So make sure you follow through this video, and right at the end I'm going to leave you with some tips on how to tackle rotational symmetry problems. So what is rotational symmetry? In a nutshell, it's the number of times a shape can fit onto itself when rotated 360 degrees. So you rotate a shape all the way through one full revolution and find out how many times it fits onto itself. So what does that mean? Let's have a look at an example. So we're going to look at just a basic square, and before I start rotating this square, it's always useful to have some sort of marker or a point just to tell you where you've started, because you can forget your starting position. So in this case I'm going to have just a little dot here just to tell me that this is where I have started. So I'm going to go ahead and rotate this shape. So here we go. So it fits on itself here, so that's 1, and I'm going to carry on. Here we go, it fits again here, so that's 2, and that's 3, and that's 4. So a shape fits on itself 4 times. And so what we say is, we say that this shape has an order of 4. Okay, it fits on itself 4 times, so it has an order of 4. Now let's have a look at a parallelogram. So here again we've got a parallelogram, and I'm going to be rotating it 360 degrees. So I'm going to start by again having a little dot to tell me where I've started. So I'm going to shove it here and say that's where I've started, and that's where I'm going to end. So here we go, and it fits once, and all the way back again, and twice. Okay, so this parallelogram has an order of 2. So I'm going to write here order 2, and usually in questions they'll ask you what is the order of rotational symmetry, in which case you say 2. Right, now does it get any harder than this? Is it just about shapes? Well, it can get a little bit more complicated, but again it follows the same principles. So let's have a look at these 3 shapes here. So let's have a look at the first one, and that's quite straightforward. So I'm just going to go ahead and rotate it without drawing a dot. So here we go. Nope, it doesn't fit, and we're back where we started, and it fits here. So this shape has an order of 1. It can only fit on itself once. So I'm going to write order 1. Now this is a special case, because what it tells us that any shape has a rotational symmetry of order 1. Okay, any shape you like, even if it's like a little, I don't know, squiggly lines, that still has an order of 1. It can only fit on itself once, and we can prove it by rotating it. So here I am, I'm going to be rotating it, and as you can see, it doesn't fit. All the way around, doesn't fit, except at the start. So it has a order 1. So you can literally have any dodgy looking shape, and it still have an order of 1. Now let's move on to the second example. So I'm going to be rotating the shape, and whoops, I actually forgot to draw a dot, so I'm going to draw a dot now. So I'm going to draw a dot right here just to say that this is where we started. Right, let's go ahead and rotate it. So here we go. Doesn't fit. Yep, it fits once, and then right back to the start, and that's 2. So it has an order of 2. Order 2. Lastly, you can now sort of get the hang of it, and you can probably tell that this has an order of 3. Now, I am writing 3, but I will prove it, so I'm going to be rotating it. So here we go. That's 1, and that's 2, and that's 3. Okay, so order 3. Now, it's all nice and easy, but the next question would be is, well, what if we had a circle? Just a plain circle. How many times does it fit on itself? Well, you can go ahead and rotate it, but you'll find out that it's always fitting on itself. And so for that reason, we tend to say that a circle has an order of infinity, you can say. So it has, whoops, I need to change to white, and there we go, infinity, or you can write it out as infinity. I mean, that's about it, except I'm not going to do these examples here, but if you can pause the video and you can have a go at them yourselves, but you can sort of have all sorts of shapes and different sizes, and you can be tested on literally anything. And usually what I've seen is in tests they have logos, so you might see a logo and it'll ask you to rotate it. I'm going to leave you with some tips, as I mentioned right at the start, and since I'm doing this on a computer, it was slightly different than how you would do it on paper. So here are my tips. Firstly, use a tracing paper to trace the shape, and then you'll need to draw a dot or an arrow to remind you where you started, and then lastly, rotate 360 degrees and count. Now please do not forget that all shapes have at least one rotational symmetry, regardless of how it looks, even if it's like, you know, scribbles, okay? It has one rotational symmetry. So that's it for this video. Please let me know if you've enjoyed this video, and if there's anything else for me to go over, and I'll be looking forward to seeing you in the next video.